Good day, this is Dr. Wortel with a solution to the exercise of the previous video. So the exercise is to prove that the limit for xy going to the vector 3 minus 4 of the arctangent of the absolute value of y plus 4 to the third times x minus 3 plus y squared is equal to 16. Now it's crucial that you attempt this exercise before, so if you haven't done so, please try this yourself and then finish watching this video. So as explained in the previous video, what we want to do, we want to estimate the absolute value of fxy minus L by this quantity, the square root of x minus a squared plus y minus b squared. And if a is 3 and b is minus 4, then in the end we get this. So we need to estimate it by the square root of x minus 3 squared plus y plus 4 squared. So let's start the estimate. So the absolute value of fxy minus L, in our case, that is the absolute value of the arctangent of the absolute value of y plus 4 to the third times x minus 3 plus y squared minus L, and our L is 16. Okay, so now we want to start in a similar way as before, so we want to use the triangle inequality, which I will abbreviate with a triangle, and to split it up into two terms. So we get the absolute value of the arctangent. I'm also using the fact that the absolute value of a product is the product of the absolute value, so I'm doing two steps at once. And then we have the other term, which is the absolute value of y squared minus 16. Okay. So let's first deal with this term, the arctangent. Well, we know that the arctangent of any angle theta is between minus pi over 2 and pi over 2. So it follows that the absolute value of the arctangent is actually less or equal than pi over 2. So it doesn't matter what the angle is. So that we have absolute value of y plus 4 to the third, it doesn't matter. This can always be estimated by pi over 2. Next is this term over here. Okay, we've got an x minus 3, and that's good, because that's something that we want to work towards. Here we want to do it in terms of x plus 4. So how can we write x squared minus 16 in terms of x plus 4? Well, obviously we can write it as x plus 4 times x minus 4. So let's do that. We get pi over 2 times the absolute value of x minus 3 plus, and say the absolute value of y minus 4 times the absolute value of y plus 4. So now we've got y plus 4, but the only problem is we have this absolute value of y minus 4, which we would like to estimate. So now note that when taking this limit, x is going to be close to 3 and y is going to be close to minus 4. So we can get y close to minus 4, therefore the absolute value of y plus 4 is going to be small in the end. So what we're going to do is, just as before, we're going to do an estimate, but we're going to assume that y is close to minus 4, so that this is small. So the next estimate is only going to hold for when the absolute value of y plus 4 is less or equal than 1. And what we need is we want to estimate this, preferably by some constants. So how do we do this? Well, we start with the estimate that we have, right? The absolute value of y plus 4 is less or equal than 1, which means that y plus 4 is between 1 and minus 1. What we need is an estimate for absolute value of y minus 4. So what can we do? Well, we can take our inequality and subtract 8, and then we get an inequality for y minus 4. So when we subtract 8, we get that minus 9 is less or equal than y minus 4, which is less or equal than minus 7. And now we're in business, because from this inequality we see that the absolute value of y minus 4 is less or equal than 9. So let's write that down. So the absolute value of y minus 4 is less or equal than 9. So if we have this estimate, then we indeed can estimate this term by 9. So let's write that down. And as before, I'm going to explain later how to deal with that condition. Okay, what's left? We have the absolute value of x minus 3 and the absolute value of y plus 4. And we need to rewrite it in terms of this over here. So for that we do a similar trick as in the previous video. So the absolute value of x minus 3, that's the square root of x minus 3 squared. And that's less or equal than the square root of x minus 3 squared plus y plus 4 squared, right? Because I'm adding something positive, and the square root is monotone. For the same reason, we can do the same thing for y plus 4, so I will skip a step there, but you get the same estimate. Right, and that is the thing that we need. So if we put this in our estimate, we get pi over 2 times the square root of x minus 3 squared plus y plus 4 squared. Plus 9 times the same square root. Now this square root here, that's precisely the distance between the vector xy and the point 3 minus 4 that we're looking for. And the same over there, and we've got pi over 2 plus 9 of that. So in total this is equal to 9 plus pi over 2 times the distance between the vector xy and 3 minus 4. Of course, we can get this less than delta, so now we can estimate this. We can estimate this by 9 plus pi over 2 times delta. And we want, as before, we want that to be equal to epsilon. Right? So now we need to solve that equation, and when we do that, well, that's very easy. We see that the delta that we should pick is simply epsilon over 9 plus pi over 2. Or less or equal than that is also fine, obviously. And then we have what we want. We have that this can be estimated by epsilon. So the only thing is we need to consider this extra requirement where the absolute value of y plus 4 needs to be less or equal to 1 in order for this entire computation star to be satisfied. So how do we deal with this? Well, we already estimated this, right? That is less or equal than that, and that is the distance that we have control about. So let's write this down. So we know that y plus 4, the absolute value, is less or equal than the distance between xy and 3 minus 4. And that's less than delta. So we see that if we pick delta to be less or equal than 1, then we have what we need. We have that the absolute value of y plus 4 is less or equal than 1. Because if delta is less or equal than 1, then the absolute value of y plus 4 is less or equal than 1. Okay, so we see that delta should be less or equal than 1, and it should also be less or equal than epsilon over 9 plus pi over 2. So just as before, we should pick our delta to be the minimum of those two things. So the minimum of epsilon over 9 plus pi over 2 and 1. So this concludes step 1, and all that remains is to do this final step where we write down the proof. Okay, so let's, as before, we're going to pick an epsilon, choose an arbitrary epsilon, and I just explained that the delta that we should pick is the minimum of those two values, epsilon over 9 plus pi over 2 and 1, so that delta is less or equal than epsilon over 9 plus pi over 2, and delta is less or equal than 1. Okay, so we've chosen an arbitrary epsilon and we've picked our delta depending on epsilon. Then if you look at the definition, the next step is to prove that if the point xy is now close to the point 3 minus 4, so that their distance is less than delta, then we have to prove that the distance between fxy and L is less than epsilon. But of course, we're going to use the equation, the inequality star from the previous slide. And notice that this is allowed because delta is less or equal than 1, and we saw in the previous slide that if delta is less or equal than 1, then the inequality star is satisfied. So then by star, we have that the absolute value of fxy minus L we showed that that was less or equal than 9 plus pi over 2 times the distance between the vector x, y, and 3 minus 4. Okay, well, that is less than delta. So this is going to be less than 9 plus pi over 2 plus times delta. Now, of course, we want to use the fact that delta is less or equal than epsilon over pi over 2. And then we get that this is less or equal than 9 plus pi over 2 times delta, which is less or equal than epsilon over 9 plus pi over 2. And that's precisely equal to epsilon. So given our arbitrary epsilon, we picked our delta in such a way that if the distance between x, y, and 3 minus 4 is less than delta, then the distance between f(x), y, and L is strictly less than epsilon. And that's precisely what we had to do. So now we write the final remark that since this holds for all epsilon, it follows that the limit for x, y to 3 minus 4 of the arctangents of absolute value of y plus 4 to the third times x minus 3 plus y squared equals 16.